So today we're going to focus on number of solutions. And so far, every equation we've seen has one solution. That is, we get x equals something at the end. However, today we will see that there's three different possibilities. What we will do is we will start off with a balance, because after all, that's basically what these equations are. Think of a scale, a balance, and you want to keep this level. You don't want this to be uneven. You want it to be balanced. So here's our little balance, and basically we are given that we have four x's, four boxes. We're going to call x because we don't know what each box represents. So we're just going to call it x. And right now it's saying that four of these x's equals 8 because this is balanced. So we'll set up our equation. We have four x's, so 4x, and this just simply equals 8. And based off of the previous videos, we can already solve this. We just divide both sides by 4 to get x all by itself, which means we're going to get x equals 2. And this is what we've seen all along. So at this point, there's only one solution. X can only equal 2. And that is because only two little squares can go in each of these x's and keep this scale, this balance, balanced. So here we can see two little squares per box will give us 8 total, which is the same as 8, so this will stay level. There's one solution. We can't put 3 in each, we can't put 1 in each, because then this would not be balanced. So to see this in action, here is 4x equals 8. We divide both sides by 4, and we get x equals 2, which is one solution. So the next problem we have is this one. We have a 2 in an x and a 3 in an x on our scale. And we're not actually sure if this is balanced, but we will find out in a bit. So to write this into an equation, we have 2 plus x. This is 2 plus x. And we have our equal sign. And then we have 3 plus x. Notice how we are using a plus sign because in the previous example, we had 4 x's. So that was 4x. This one, we have 2 plus x. We only have 1 x and we have 1, 2. So that's 2 plus x. Anyways, so if I were to solve this using this scale, I see that there's x on both sides. So I need to combine those first. I just want 1x. So what I will do is I will remove the x from both sides, like so. And we get 2 and 3 on both sides. And so if we do this to our equation as well, I'm going to subtract x from both sides. We will get 2 equals 3. Now this should spark something in you because 2 does not equal 3. And if we had this on a scale, this would look something like this. It would not. 3 is more than 2. So it's not balanced. So in fact, when we had these x's originally, this was not balanced to begin with. But we didn't know that until now. So now 2 does not equal 3. Therefore, there is no solution to this equation. There is nothing we can put for x that will make this level. And that is because if we have the same number on both sides, 3 is greater than 2, so this one's always going to be bigger no matter what. To show you this on a whiteboard, we have 2 plus x equals 3 plus x. We subtract x from both sides. We get 2 equals 3, and that is not true, so we write that line. So the answer is no solution. Now, let's say we have 2x on one side, so 2 plus x on one side, and 2 plus x on the other side. In the previous example, we had 3 here, but I went ahead and replaced it with a 2. So we would have 2 plus x equals 2 plus x. And again, to solve this, I would want to get the x's on the same side, so I'm going to remove these, and you'll see why, because here we're trying to move the x's together, so I'm subtracting by x on both sides. But in doing so, again, we're eliminating the x on accident, I guess, and we are left with 2 equals 2, and you can see this here. We take x from both sides, we're left with 2 on both sides, and that is true. In doing so, 2 equals 2 is a true statement, whereas in the previous example, we had 2 equals 3, which is false. Therefore, we have infinitely many solutions. Now, this means that whatever I plug in for x will keep this equation balanced. So for example, if instead of x we had, let's say 3, then this would be 2 plus 3, which is 5. And on the other side would be 2 plus 3, which is 5, and 5 does equal 5. If I plugged in 14, same thing. I would get 2 plus 14 and 2 plus 14, which is the same on both sides. Now, on a whiteboard or on paper, it would look something like this. We have 2 plus x equals 2 plus x. We're trying to combine like terms, and in this case, I wanted to get x's on both sides of the equal sign. And in doing so, I eliminated the x's. There weren't no x's left, and we were left with this statement. 2 equals 2, which is true. So there are infinitely many solutions. To recap, for a number of solutions, to determine how many solutions there are, you will solve for the variable. It's usually going to be x, but whatever variable there is, you solve it like a normal equation. And if you get x, or whatever your variable is, equals something, then you have one solution. And that solution is that something. If you get something that does not equal something else, so in the example we had 2 equals 3, those aren't equal, so we have no solutions. And if at the end we get something equals that same something, so 2 equals 2 for example, we have infinitely many solutions.